Hello and welcome back. We continue our introduction to SQL. Previously we've looked at how we can retrieve information from a database, and now we start by putting information into the database. We start by creating schema and tables. So before we start working with a database, we need to define a database schema that defines which entities we have and how we can split this into appropriate tables. And when we define a table, we also need to specify which data types for which column we are going to use and how these tables should be related. Before we had our minimalist example already with only two tables with very few variables or columns. Of course, in a more realistic scenario you would have many tables with many more variables. But let's stick with a simple example. We describe our storage locations and our samples. You notice that we have storage ID twice as a primary key in the storage table and as a foreign key in the samples table. So how do we create a schema? We tell the database create schema and make an amendment if it doesn't already exist to prevent an error. If we didn't write this, then the database would say this schema already exists. So we say create schema if not exist RDM, so we use the schema called RDM. Semicolon to indicate now that the command ends. As a convenience, we also sort of change the directory in the database and said search path to RDM, so we don't have to specify RDM all the time. It's better to do this so you make it more explicit, especially if we have a table with multiple schema, but as a convenience function we can set the search path here. So how do we create tables? Here we need to think about the order in which we create the tables, because we need to create the tables that are being referenced first. If we want to start from a clean state, we say drop table if it exists, and then table that is there, RDM samples, or drop table if it exists, RDM storage. That wipes those two tables from the database. Be careful if you say drop table star, then you wipe everything from the database. So you really need to be careful with this command. So let's start here with a clean slate. And now we create the table. Command is create table, unexpectedly, and then we create the table name. We say RDM, this is our schema name, dot storage. So the general format is schema name, table name. And now we need to specify which columns we have, that means which variables and which types and if there are any constraints. Finally, we define which of those variables is going to be our primary key. Let's start with the storage one because this is referenced later. So we say create table RDM storage. Storage ID was our primary key for this table. Instead of saying just int, because we use integers in our example, we say int, so it's type integer, generate always as identity. And this tells the database do it automatically and use an int as data type, so we don't have to worry about it. This is process specific. Other databases will have slightly different formats for it. And then we have two actual columns or variables that we want to treat. We have the storage location, and here that was a string. So we say varchar and we limit the amount of characters that we have. So varchar with the length of 100. That should be sufficient for most, but you can also choose maybe 500 or something like this. And then we add some constraints. We tell the database it must be unique, so you can have each storage location only once. This avoids that a user accidentally adds a storage location twice. We also say it mustn't be null, not null. So that means that the user, when adding to this table, needs to specify a character value of maximum 100 characters. So varchar 100 unique not null ensures that we have a unique storage location, and if we add to this table it needs to be given. We also added a last update one, and that is a timestamp. It's a specific data type that contains date and time. We also add some constraints to it. We add the current time zone that we are operating in, so we don't have to take care of that as well. and then we add a default value, and the default value is now, or current timestamp in this case. So that means if the user doesn't specify it, the database fills it in automatically. Right? So remember here, timestamp is a special variable type. It contains the date and the time, and we don't have to fill it, but the database makes sure there's always a value to it. Now we focus on the samples table. This table holds information about our samples. We have the primary key for each sample, and we have the relationship to table storage. So here we make use of the primary key that we defined in our table previously with a foreign key. We start as before. CreateTable RDM samples as the table name. Then we give it the sample ID just as we did before, int generated always as identity to make sure that the database does this automatically. If we want to add to this table, we need to have a unique value, so no sample can be added twice. Not null means we have to enter a name. Last update as before, timestamp with time zone default current timestamp, so that if the user doesn't define it, the database fills it in automatically, and we define the primary key. Now we do the location and the relation between those two tables. So first of all, we need to add the respective column, storage ID. This is an integer. And now we need to tell the database that we have such a relation. So we add a constraint to the table. And we add a constraint and we give it a name, foreign key storage. So this is for our convenience, and say, okay, we want to relate this to a foreign key, and we relate it to the table storage. And now explicitly for the database, we tell it it's a foreign key on storage ID. And then we need to tell the database where it will find the storage ID. So that means our table samples now references the storage in the same RDM schema, and in that table the storage ID. And then we also need to specify what happens if we, for example, delete the storage locations, because then we would have undefined values in our samples one, and we say if this other table is deleted, we set the values to null here. We could also tell the database if one table is deleted, delete all other tables, and so on. Now we start filling the table storage. Again, we need to keep the order in mind. The samples references the storage, so we need to fill storage first. So we start with the list of variables. Insert into specifies we want to add now a value to this table, RDM storage. And now we add the storage locations. In our case from Harry Potter. So these are the values that we have. Remember that we don't need to fill ID in last update. The ID is forced to be auto-generated by the database. This is how we set up the table. So we're not allowed to interfere here. And last update is optional. We could specify it here, or we don't, because we said if an interaction is made with this table and a row in this table, last update is filled automatically by the database engine. And now the database can do its internal checks. Remember from the table definition, right? This field must be filled. Storage location, unique, not null. So each value can only appear once, and you would get an error message if you would try to add a storage location twice, or if you were to give a name as an empty string. So this is already seen here. The database now checks that we have the storage location twice on our list, and it will throw an error. Then we can fill the table samples. So the naive approach would be the same procedure as before. We fill each value manually and explicitly. But then we would have to look up which storage ID to look up ourselves. So this is very error prone and inconvenient. And the whole point of having these relationships in the database schema is not to do this manually. So how do we do it instead? The answer is let the database do it. So we insert into the samples table the storage ID, but we need to retrieve that, and the sample name. Remember again, last update will be filled automatically. Now, how do we get those? We need to find out the storage ID. Remember earlier how we can retrieve information? That's done with the select statement. So we've selected the storage ID, this is the value we're interested in, from the storage table, and now the where clause gives us a constraint. And here we can type, for example, manually one of the storage locations we're interested in. And then in brackets, the select storage ID from RDM storage where storage location equal our string. The return of that is then used as input for storage ID. So the schemata allow separate namespaces in databases, and tables belonging together do not interfere with other set of tables. If you want to create tables, we use the CreateTable command. Here we specify the data types, the primary keys, any constraints that we have, and references like foreign keys and so on. Doing so enables the database to check and enforce all the conditions that we have envisioned and nail down our database schema. If we do that, we need to keep the order of the relationship in mind. We can use the select statement to refer to parent tables when finding child tables as well.